Welcome dear students. In the previous lecture, I explained you about basics of clipping and I given you idea about what is clipping. So clipping is simply identifying the portion of an image whether it is lying within the visible region. So for example, if it is a viewport, okay, so whether the object is lying within this boundary or within this rectangular region or it is lying outside this rectangular region. So whenever the object lies, some portion of the object lies within the visible region or some of the portion of the object lies outside the visible region or the viewport, then it has to be discarded. Any part that is lying outside the viewport or a window, that should be discarded, and anything that is lying, that is visible and that should be viewable to the user, it should be accepted. Okay, so the process through which it is be done, it will be done is called the clipping. Okay, so I talked about that and I also talked about the applications of the clipping. Okay, and I also explained you about what is point clipping. That is one of the method through which any point can be clipped with respect to certain conditions of finding it out the value of x that should lie within the range of x maximum and it should be greater than x minimum. Okay, likewise we have y minimum. Okay, and the y value must lie within the range of y minimum to y maximum. Okay, so this is any point that is lying within this range, that will be the acceptance, the point will be accepted and it should be made viewable at within the viewport. Whereas any point that is not following this inequality and it is lying outside, that is it is reaching beyond the x maximum somewhere here, or if it is reaching beyond y maximum, y minimum, or it will be x minimum, so these points will not be visible on the screen. Okay, so this is simply selecting points. So what about the constructed objects? That is, for example, I'm taking here the algorithm that is called a line clipping algorithm. So what will be the process to clip the line, to clip the line with respect to any viewport or a window? Okay, so I'm saying what differently every time, that is window and viewport, because the clipping can be, I told you about that, that clipping can be done in two different ways. That is, at the time of windowing, means when we are showing an image at the world coordinates, then there also the clipping can be done. Whereas the clipping can also be done, the complete object can be mapped onto the device coordinates, and then after the clipping can be done. So at two levels the clipping can be performed: at the world coordinate level, that is the at the window level, as well as at the device coordinates or the screen coordinate level, that is at the viewport. That is why I'm referring every time viewport or a window, and this viewport or a window will be a rectangular region that will be defined by certain range, that is x minimum value and with y minimum value. Okay, and x maximum and y maximum. Okay, across which the line or a point or any object will be clipped. So this will be called a clip window. I told you about that. An object that will be clipped against a window, that will be called a clip window. Okay, so let's talk about line clipping algorithm, and it was given by Sutherland Hodgman Sutherland, it was given by Sutherland, so not Hodgman, Sutherland. So that is why it is called the Sutherland Hodgman clipping algorithm. Okay, so what it is all about, let's see. Okay, so what it says, the algorithm explains how the clipping of a line can be done. So here you can see it was given by Cohen Sutherland. So it is called that Cohen Sutherland line clipping algorithm. Okay, so we split the complete region in Cohen Sutherland line clipping algorithm. We split or we distribute or we divide the complete window into 9 regions. Okay, so this is a window. So this red marked box is will be considered as a window or a viewport, and we divide further with an imaginary line. We divide the complete window into 9 regions. Okay, so we call it as, for example, region 0. Okay, and region 1, region 1, let's say region 1, region 2. Okay, so likewise region 3, region 4. Okay, region 5, 6, 7, and 8. Okay, so starting from 0, so that complete screen is divided into 9 regions, and each region is provided with a 4-bit code. Each region is provided with a 4-bit code. Okay, so this will also be a 4-bit code. All the regions will be of 4-bit code. And how this encoding will be done, we can follow any rule. We are just dividing, so we are considering everything across these boundaries will be considered as a right, it will be considered as a left, it will be considered as a above, or you can call it as a top, and this will be considered as a bottom. Okay, let's write one second. Above, top, bottom, right, and this is left. Okay, so we call it as a, we will follow the encoding scheme, that is we call it as a ABRL, or we can call it as a TBRL, top, bottom, right, and left, or above, bottom, right, and left. And how we encode it, so it is, this complete region is not following, it is not left, it is not right, it is not bottom, it is not above, so it will, all bits are set to 0. Okay, the rest of the regions are how it will be coded. Okay, so when we are moving towards the right, so right bit is on. Okay, so we can write over here T B R L. Okay, so right bit is on, and when we are moving left, okay, so here I'm writing TBRL. TBRL. Okay, so here you can see the L is set. Okay, likewise if I write a code for it, that is TBRL. Okay, so it is bottom, so this set is 1, rest of them are 0. Okay, this is above or top, TBRL, so it is the top part, top is set to 1. So these regions are coded. Now how we can go for other regions, that is if I find the intersection of this, so it is at the top, top is set 1, okay, and it is at the right is set 1, B and RL, B and RL 0, left is set to 1, okay. Likewise, if I try to code it, the intersection part of region 8, let's say, so I write it T, B, R and L. It is on the right hand side, so the right bit is set to 1, and it is at the top bit is set to 1, and rest of the bits are 0, okay. So same goes with this, or another method can be that simply perform the XOR operation between these two codes, XOR operation between these two codes. So I hope you will be able to understand me. And if you will perform XOR operation between these two codes, you will get this. XOR operation between these two codes, you will get this. And we can follow this rule as well to write the all the codes of the complete screen, that is 9 region, okay. So simply it is showing that if we are setting first bit, okay, first bit as 1, first bit is set as 1, this is bit set as 1, then we are reaching above, and we are reaching above y max, okay. And if we are setting up second bit, that is this, sorry, this is the second bit, we are moving from here, this is the second bit, okay. So if we are setting this second bit, that we are setting up or moving towards the bottom, we are, the y is less than the value of y minimum, okay. So this is the range, that is y minimum, okay. We are ranging from y minimum to y maximum, okay. And if this set is 1, if we have the point is here somewhere, then means we are setting the bit that is bottom as 1, okay. Now the third bit, that is the right of the right edge, right of the right edge is this, and we are moving away from the x maximum, so this is x maximum, okay, and we are moving away from it, okay. So that is the right bit is set to 1, it is indicating that we are moving right of the right edge, we are moving above of the top edge if the first bit is set 1, if the second bit is set 1, we are moving below to the bottom of the edge, and if its third bit is set, then the right of the right edge we are moving x is greater than x max, and if it is so, if we are setting up fourth bit, this fourth bit as 1, then we are moving left of the left edge, this is the left edge, okay, and we are moving left of the left edge, so we are moving beyond x minimum, okay. So in this manner we have coded the all the 9 regions of this screen. I hope you are able to understand how these regions are outcoded. So every region is provided with an outcode, or outcode is of 4 bit, okay. And we have followed this above, bottom, right and left mechanism, or we can call it as a TBRL. Any order can be used, okay, but we are sticking to this and we are following it, okay. You can use RBL a or something like that, no problem with this. So we have to simply provide the outcodes, different outcodes to all the regions, accordingly the programming will take place, okay, when it will be implemented in C or in any other language. So moving ahead, so this is the, now you are able to understand how these regions are coded. Now moving ahead with it, now when we talk about, when we have this region, so this will be considered as a window or a viewport, so this region will be the part of the screen where the image will be shown or displayed, okay. So anything that is available within this screen, okay, will be shown on the screen. That is, anything that is going beyond that screen will be clipped and discarded. Okay, so simply, first point, that is checking for trivial acceptance, how we can quickly accept a line or how we can quickly reject a complete line by looking at the outcodes of a line endpoints. Okay, so each endpoint of a line segment is assigned an outcode. Whenever we will draw a line, whenever we will draw a line, okay, somewhere like this, for example, if I've drawn a line like this, if I've drawn a line like this, so different lines are drawn. So each endpoint of this line, each endpoint of this line will be provided with an outcode. Okay, okay, so each and every endpoint will be provided or assigned with an outcode. Now if these 4-bit outcodes, so we can follow one method, that is simply, if we perform the 4-bit codes yields or give you 0, the line, if line can trivially accept it. If we will perform AND operation between two endpoints assigned with an outcode, and if we perform AND operation, so that if it is yielding 0, so it should be trivially accepted. Or we can say, if we are performing OR operation, not the AND operation, if we perform OR operation and it is yielding 0, then it will be trivially accepted. Okay, and if we perform AND operation between the outcodes of two endpoints, then, and it is giving you the non-zero result, if it is giving you the non-zero result, then the line will be trivially rejected. So here we are trying to say that what are the two cases through which we can quickly accept a line or we can quickly reject a line. Okay, other part can also will also be computed where the some part of the line will lie inside the visible region and some part will lie outside the visible regions. For example, this is the case. Okay, in this case, some part is lying inside the visible region and some part is lying outside the visible region. Okay, so in this clipping will take place. Here I am considering the basic two cases: quickly acceptance and quickly rejection, so that we don't have to clip anything. In these two cases we don't have to clip, we can quickly say that this is the visible part and it should be shown on the screen, and this complete line is completely rejected and should not be shown. Okay, or should be ignored or discarded. So every endpoint of a line will be provided with an outcode, and if I perform OR operation between the two outcodes, if one outcode is given with C not and another outcode is given with C and the line is given with a point P naught and P end. Okay, so let's see how it will work. If I draw a line from here to here, okay, so what is the outcode of it is 1001. Okay, so let's say this is P naught and this is P end. Okay, so this is the P end, and what is P naught? 001. And perform the AND operation between it. If I perform the AND operation, what will happen? 1 and 1, 1, 0, 0, and it will be lead to 0. Okay, what it will give? Non-zero value. if AND operation results in with the non-zero value, so the line can be trivially rejected. Let's draw a line from here to here. If this is P naught, this is P and this is C naught code, this is C let's say. Okay, so perform AND operation 0 1 0 0 and 0 1 1 0. Okay, 0 0 1 0. So this code is non-zero. Okay, so this line can be trivially rejected. Okay, and when we perform OR operation, okay, and when both the outputs are zeros, and when we perform OR operation between these outputs, so that will yield to 0. Okay, so simply it will give that we should trivially accept the line. Trivial means the complete line is lying within the visible region. Okay, so this is the case where we can trivially accept and trivially reject a line. Okay, so let's follow the rule. We have an algorithm. We will go step by step and we will find out how the this line clipping algorithm works. Okay, let's see what it is saying. First we will calculate the positions of both end points of the line. Okay, let's draw once again. Line regions. Okay, and let's write out the codes. All zeros that we are following: top, bottom, right and left. Top में first bit, bottom में bit set, right में left. Okay, what will be the code for it? Okay, like this. So all the codes are written. So first step, that calculate the positions of the both endpoints of the line, where the position of the line lies, in which outcode the points are lying. So this can be checked out by the x minimum and x maximum values given to you. Accordingly, we can find out in which outcode it is in line. Okay, then perform OR operations on both these endpoints. So any outcode is given. If I perform OR operation, for example, if I perform OR operation, so it will yield to non-zero value. So means simply to accept it, if I perform OR operation, it must give you the all zeros value. So in which case it will give you the all zero value when a line lying within the viewport. So this is the viewport. This is the viewport. Okay, so when a line will be lying within this region, then it will be trivially accepted, with a case that when the both outputs, when we perform the operation between the both outputs C naught and C end, बीच में हम क्या परफॉर्म कर रहे हैं और ऑपरेशन, और ये रिजल्ट कर रहा है all four zeros output, then it will be trivially accepted. That complete line will be accepted and it is lying within the visible region. So then the line is considered to be visible. Okay. Else उसके अलावा क्या कर सकते हैं? Perform AND operation on both endpoints. Okay. Then next step is perform AND operation between C naught and C end C naught and C end is the outcode of the endpoints. P naught is a point and P end is a point of a line. Then the outcode related with P naught is C naught and P end is C end, and we perform AND operation between them. If it will yield non-zero value, then the line is completely lying outside the visible region. So it should be completely discarded. Okay. And else, if this AND operation yields zero, mean it is the case in which the clipping will occur. This is the case where the clipping will occur when we perform the AND operation between the outcodes and it yields or gives the result as a zero value. Okay. So in such cases the clipping has to be performed. Let's see. I draw a line from here to here. Okay. So first code is 0 0 0 0 and second code is endpoints are these, and you consider it as a P naught and Pn, and 0 1 0. Okay, now when we perform AND operation, it will yield to 0 0, both should be true, then only it will be set to 1 0 0 0. So means the result is 0, means clipping has to take place across the edge. Across this edge the clipping has to take place. So line is this, such lines will be considered as a case of the clipping. So line is considered with the clipping case. So we have followed the 3-step procedure. First one is it will be assigned with a code. Okay, code will be assigned. Then we perform the OR operation between the outcode, and if it yields 0, means trivially accept the line, means clipping is not required. Third, if we perform the AND operation and AND operation yields non-zero value, then it means trivially reject, means simply reject the line and no clipping is required. Fourth case, that is if we perform AND operation and the value gives the result as a 0, so in that clipping will take place. Okay, so across that edge the clipping will take place. So intersection points has to be calculated across this edge. Intersection points will be calculated. So how we will calculate this intersection points? Let's see. Okay, so this is the viewport. Okay, and we have defined a viewport by xmin, xmax, okay, and ymin and ymax. Okay, so this rectangular region is defined by these values. So the line can be clipped across any of the edge when we are extending it with the 9 region code. Okay, and each region is provided with a code. Okay, so if a line is clipping and the clipping has to take place, then for example if a line is drawn from P naught to P end, okay, So across this edge the line will be clipped. Okay, so how we are going to calculate this intersection point? Okay, in the same manner, when the line will be clipped across this edge, how we are going to find the intersection point across this edge? Line will be clipped across this edge, let's say. Okay, so how we are going to find this intersection point? When this edge, how we are going to find the intersection point? So what rule we are going to follow? So whenever we will draw, when we draw a line, it acquires certain slope. Okay, if a point and slope of a line remains same throughout, that you already know. Okay, whatever point you take over here, for example, if I draw on a line from 0 0 to 10 10. Okay, by taking 1 1 point, this is 1 1 1 1 2 2 3 3, likewise. Okay, so what will be the slope? 10 minus 0 and 10 minus 0, that will lead to 1. If I have taken any one point within this line that is lying on the line, for example, let's say 5 5, now what will be the slope of this line? Because it is a part of this line only, the segment of this line, then it is 5 0 and 5 0, that will also 5 by 5 1, and that is 1. Slope is 1. So line of a slope remains same throughout the line. Okay, if you take out any point of that segment, then if you try to calculate the slope from the start point to the end point, then it will gives the same slope. So what I'm trying to make you understand over here is, you know the P naught value, you know the P end value, you can calculate the slope from here. Okay, so let's say P naught is x1 and y1, and P end is x2 y2. So what will be the slope? y2 minus y1 upon x2 minus x1. Okay, now if I want to find out the point of this intersection, what I know right now with this point, the value of x. So what will be varying whenever I'll cut this line across this edge? What will be varying? That is y only. You will not be varying with x. Okay, is it clear? So for example, let's say this point is x3 and y3. Okay, so what will be the slope from p0 to x3 and y3? Let's say this is p0 dash. Let's say this is p0 dash. p0 to p0 dash. What will be the slope? p0 के पॉइंट्स क्या है? x1 y1, और p0 डैश के पॉइंट्स क्या हैं? x3 and y3. Okay, so what will be the slope in such case? M will be equal to y3 minus y1 upon x3 minus x1. Okay, so both these slopes will be equal because the points are lying on the line. So we may write it like, okay, or simply I can say that y, just multiply it. So what we have to calculate over here, that is y3. The reason being because we know the x3, that is x is this. So on this x, y is varying. We know the value of x min because the viewport, the size and the window size will be given to you and will be known to you basically. Okay, so from here we can write m multiplying it by x3 minus x1, okay, plus y1 is equal to y3. Okay, from here y3 can be calculated because when we are drawing a line, y1 will be known to you from the p naught. M slope, this is y2 minus y1 and x2 minus x1. Okay, this will be known to you, and x3 minus x1, x1 will be known to you. And what is x3? X3 will be x min. Okay, and when we are doing this across this edge, so we will be having x max. So this formula will be changed into y3. Here we will calculating y3. Okay, we will be calculating the value of y here. Okay, and what will be static? Y1 will be given to you, slope will be given to you, and x3 will be changed into x max minus x1. So it is the general form for the when the bit is set of the right की bit का क्या मतलब हुआ कि आपका 1 0 0 0 in this case. So, okay, right का ये ABR है, that is 0 0 1 2, ये code है 0010 ABR. Okay, so it is shown here. We have the slope y2 minus y1, that is p naught and p end. Okay, when bit 1 is one line intersect with the left boundary, first bit is set. Okay, bit 2 is set, bit 3 is set, and bit 4 is set. Okay, that is 1 0 0 0. 4 bit is set, 3 bit is set, 0 1 0 0. Bit 2 0 0 1 0. Okay, 0 0 0 1. So this bit is set here, this bit is set here, this bit is set. So we are trying to say, okay, so if bit 1 is one line intersect with the left boundary, what is the code of this area? What is the code of this area? ABRL, and it is left 1. Okay, if bit 1 is this set, p नॉट का कोड क्या है? अगर c नॉट है और इसका कोड ये है तो इसका मतलब क्या हुआ कि ये इस बाउंड्री के अक्रॉस इंटरसेक्ट हो रहा है. तो उसके लिए हमें क्या फॉर्मूला निकालना पड़ेगा? वी विल बी कैलकुलेटिंग y3, means this y will be calculated here because y will be varying across this edge and x will remain same. Okay, so we have y3 is equal to y1 plus m into x minus x1. So I have written x3 over here. Okay, so to make you understand it in a better way, and this x3 may vary from x min एक्स मैक्स। तो यहाँ पे फॉर्मूला यहाँ पे एक्स मिन का ले रहे हैं क्योंकि हम यहाँ पे एच के क्रॉस कर रहे हैं, और यही फॉर्मूला सेम फॉर्मूला यहाँ यूज हो रहा है। ओके, और यहाँ पे सिर्फ वैल्यू क्या चेंज हो जाएगी इस एक्स की, यहाँ पे एक्स मैक्स हो जाएगा, विंडो या व्यू पोर्ट कुछ भी हो। ओके, सो मैक्स हो जाएगा। क्लियर? सो फ्रॉम हियर ओनली वी कैन कैलकुलेट द वैल्यू ऑफ x3। जब हमें ये दिया हुआ था, हमने यहाँ पे देखते हैं इसको फॉर्मूला, y3 is equal to y1 plus m, and I have written x3 minus x1। ओके, सो मान लीजिए अब हमें इस एच के अक्रॉस निकालना है। ओके, तो पी नॉट की वैल्यू क्या होगी, x1 y1, इसकी वैल्यू क्या होगी x2 y2। ओके, और इस एच के लिए हमने क्या ले लिया, मान लीजिए x3 y3। ओके, बिगर लाइन की स्लोप, बिगर लाइन की स्लोप क्या होगी, दैट विल बी x2 सॉरी y2 minus y1 upon x2 minus x1, that is the slope। okay, now for the smaller line, जहाँ जिस एज के अक्रॉस कर रहे हैं, एज हमें आइडेंटिफाई कर लेंगे विद द बिट 3 सेट 1। तो आउटकोड के थ्रू हम आइडेंटिफाई कर लेंगे कि किस एज के अक्रॉस इंटरसेक्शन फाइंड आउट हो रहा है। ओके, तीन एम की वैल्यू, और यहाँ पर इस शॉर्ट लाइन के लिए क्या होगा, दूसरी x3 y3 के लिए स्लोप इक्वल टू x3 y3 minus y1 divided by x3 minus x1। okay, now we have to calculate the value of x3 from here, because क्योंकि हमें x3 की वैल्यू निकालनी है, बिकॉज x इज वेरिंग एवरी टाइम, कि अगर हम लाइन कहीं भी कैच करेंगे, और क्या सेम रहेगा y, सो इट इज लाइंग ऑन द y सेम रहेगा, और x वेरी कर सकता है अगर हमारी लाइन इस एज के अक्रॉस में कट करेगी कहीं पर भी। तो यहाँ पे हम क्या कैलकुलेट करने वाले हैं, x3 कैलकुलेट करने वाले हैं, और y3 हमें गिवन है बिकॉज इट इज y मिनिमम। ओके, बिकॉज इट इज कटिंग डाउन अक्रॉस दिस एज, और एज कैसे पता चल रही है हमें, इसके कोड के थ्रू, कि किस कोड के अप्रॉक्स हम with respect to what code we are finding the intersection। okay, so here the what will be the value of x3, let's calculate it। x3 will be equal to, okay, x3 will be equal to x1 plus, okay, plus y3 minus y1 divided by m from here only। okay, now this y3 is what, y3 is y minimum, so here we will write y minimum। if this would have been cutting down across this edge, then this y3 would have changed into y maximum। okay, so in this manner we are finding out the intersection point across the edges, how we compute। so we can compute across this edge, we can compute across this edge, we can compute across this, and all four boundaries are covered। so we will be using these formulas to compute the intersection points across these edges। okay, so we will see how, with the help of an example, how the computation will take place, so where these formulas will be used। okay, so okay, so So don't go with this algorithm right now. I'm just trying to erase it. Don't go with it. What I have shown you earlier, you follow it. Okay, so don't follow this algorithm. Don't go through it. Now let's understand certain cases when the clipping will take place. I have considered these 5 cases. So 5 different lines are drawn and it has got different outcodes. Let's extend the outcodes and rewrite it to understand it in a better way. Okay. Okay, so these are 5 different cases. What will happen? Let's extend this line. Let's say this line is line. Sorry, this point is lying on the line, or maybe extended further. Okay, so this is lying beyond this line. Let's say this is the output for this point. Fine. Let's take first case, that is case AB, that is the line A and B. Okay, now perform the line clipping algorithm on this. Two endpoints are given. Okay, then the outcode is 0 0 0 and the outcode is 0 0 0. Okay, so when we perform OR operation, okay, and when we perform OR operation between these two on endpoints, it will give us 0 0 0 0 output. Okay, means that this line is completely lying on the within the visible region, so it should be directly accepted. Okay, so simply no further clipping algorithm will run. So simply here only the clipping algorithm will end up. Okay, now let's understand the case with case CD. Now here the outcode is 0 0. Okay, and what will be the outcode of it? That is on the right side. So 0 0 1 0. Okay, now when we perform the AND OR operation, so it will not yield to 0 value. Okay, and when we perform AND operation, between these two outputs, 0 0 0 0 0 1 0, AND ऑपरेशन परफॉर्म करेंगे तो क्या होगा 0 0 0 0. So means some part of the line is lying within the visible region. If it would have been a non-zero value, so we'll discuss. So it means it is simply lying, some of the part is lying within the visible region. Now means we have to compute the intersection point. Okay, what will be the method to compute the intersection point? Here you can see this will be the x max. Okay, and this will be the x min. Now here the x max will remain same throughout. You know the x max, but you are not known with the y value. Okay, and you know the value of d, you know the value of c. With the formula of intersections, we can calculate the value of y from here. Okay, with that formula. Okay, so y की value हम निकालते हैं. Y is equal to, that is y1 plus m into x max minus x1. Okay, इस तरह से फॉर्मूला लिखा हुआ है. So simply I am trying to say over here that the intersection point will be calculated. Okay, so this line will become, let's clear it down. This line will become like this, that will be d dash. Okay, and this line will be clipped. Again, to check that this output, we will perform the OR operation, and we can easily see that two endpoints are lying within the visible region, all zeros, and means its line will be trivially accepted with this case. Okay. Now considering EF, what is EF? This EF it is. Okay. So, so two endpoints are given, and the endpoints are 0, 0, 1, 0. Okay. When we'll perform the AND operation between these two endpoints, what it will yield? 0, 1, 0, 0. So it is a non-zero value. So it is simply the line is lying outside the visible region and it will be trivially rejected. Then after rejection, no clipping will take place. Simple. Okay. So these two cases are very important to understand. Now see, if I extend this line, I told you this line, let extend this line up to this point, that is G. Okay. And I'm drawing a line over here. Okay. So what is the outcode of this region? That will be above 1, 0, 0, 0. Okay, what is the outcode of this region? That is left. So 0, 0, 0, 1. Okay, and what is the outcode of this region? That is 1, 0, 0, 1. Fine. Now follow the, now apply the clipping algorithm. So if I perform the OR operation between these two outputs, so what it will give? Non-zero value. It is now no zero. It should be, it cannot be trivially accepted. If this line cannot be trivially accepted, let's apply trivially reject condition. If I perform AND operation between these two codes, so it will lead to what? 0. If it would have lead to the non-zero value, then it should have been trivially rejected. So when we perform AND operation between these two outcodes, it yields all zeros. Fine. So the clipping will take place. So as you can view on the screen, simply this, these two lines, this line is completely outside the visible region as you can view on your screen, and this line is, some part of the line is lying within the visible region. But when we apply the line clipping algorithm in both the cases yields 0. It is GH and it is IJ. See, if I apply outcode and operation, then it will use 0, and if I apply and operation between these two outputs, because the outputs are same, so it also yields 0. So in both cases the clipping will take place. So this you have to remember. Okay, so this is the shortcoming of the sometimes unnecessary clipping is done in case of line clipping algorithm. Okay, so when we do the clipping of this, okay, so while clipping we follow the cyclic order that you have to keep in mind. Once you have done the clipping of across this edge, you will receive I dash. Okay, now the clipping will take place from J to I dash in this manner. Okay, so that is J dash. Okay, so I dash and J dash will be accepted and this will be discarded. In this case you have to move from G to H. Now the clipping has to be done. You have to clip this part across this edge. So this part will be rejected. And when you apply again, re-execute the algorithm. So now you can see you are left with the code 100 and you are left with the code 1001 here 100. So when we perform AND operation between this 1001 and 1000, okay, when we perform AND operation, what it will yield? it will 0, 0, 0 and 1, and it is non-zero. So what does it mean? So this complete line, after one click, after clicking one time across this edge, you can completely discard this line. Okay, so same procedure will be followed one after another. एक के बाद एक आप ऑपरेशन परफॉर्म करते हैं. पहले आप चेक करते हैं कि लाइन कम्प्लीटली एक्सेप्टेबल है या नहीं, या फिर आप चेक करते हैं कम्प्लीटली रिजेक्टेबल है या नहीं. फिर आप चेक करते हैं कि वेदर द लाइन कैन बी क्लिप्ड और नॉट. So two methods will allow you to accept and reject, and another method will allow you to clip. Okay, so one more method that will allow you to identify whether the line can be clipped directly or it should be rejected directly. If a line is drawn somewhere within the boundary region or outside the boundary region, you can check if the output position of the one bit at one location is same throughout in two outputs, then that line can be rejected trivially. What does it mean? For example, if I draw a line here, okay, so at position right and right, this at the same location, the bit is set to 1. It can be said that this line can be trivially rejected. If I draw a line here, so see, one of the location, when the two bits are same at one location, then this line can be trivially rejected. Likewise, if I draw a line from here to here, see, at this location the bit are same in two outputs in set to 1, then it can be trivially rejected. So in this manner also, this is also one of the method through which we can do the rejection. Okay, so in short we can say endpoints pairs are checked for trivial acceptance or rejection using output. Endpoint pairs are checked for trivial acceptance or rejection using output. If not trivially accepted or rejected, divide the line segment into two at a clip edge and iteratively clip by test trivial acceptance or trivial rejection and divide into two segments until completely inside or trivial rejection. तो आपको ये बार बार अप्लाई करते रहना है कि जैसे कि आपने यहाँ पे अप्लाई किया. For example, these two outputs is made available. Okay, so the complete line, how it will be clipped. First, let's say this line will be clipped across this edge. We are left with F. Then the again the algorithm will run. We will see the output of this. Then across this edge line will be clipped. Okay, then again we are left with H. So this line will be checked. Complete algorithm will run for GH. Then this point will be we will receive. Then the algorithm will run for this part and it will be trivially accepted. So recursively, one after another, we will iteratively clip by testing a trivial acceptance and or trivial rejection, or divide the line segment into two parts until completely inside or completely outside is done with a line. Okay, so this was all the process of your line clipping algorithm that we have followed. Okay, let's go through certain advantages and disadvantages of the line clipping algorithm, and a few things that you have already understood now. All our checking of output requires only Boolean operations that you have seen, that we require simply the Boolean operations. By checking the Boolean operations only, we can decide whether it is trivially accepted, trivially rejected, or clipping has to be performed. Then we have advantage, do intersection calculations only when they are needed. Okay, so we do the intersection. This is a contradictory point with the advantage, because sometimes intersections are calculated when it is not necessary, but still it is advantage. It can be easily extended to 3D programs, and it is easy to program, because it can be easily implemented with the help of certain programming language. So by reading out the outcodes, you can decide the line is within the visible region or outside the visible region. But we have another algorithm that is called Liang-Basky line clipping algorithm, and it follows different method of line, that is intersection of a line, that is a parametric equation of a line. So it is more efficient than that of the Cohen-Sutherland line clipping algorithm, and we follow it. But in our course, it is Cohen-Sutherland line clipping algorithm. That is why I have covered that. Okay, so these are the few advantages, and if I go with the few disadvantages, then we will do unnecessary clippings that you have encountered. I explained you with the case of a line, that in which the line is the same line that is lying with the same code lying within the visible region, and with the same code that is lying with outside the visible region, where the unnecessary clipping is performed. Not most efficient method. It is efficient only when completely the line is lying completely outside and completely inside. Okay, so and because we have to in one go, we are not able to find out which part of the line is lying within the visible region or outside the visible region when the clipping is taking place. Okay, so we have to iteratively apply the recursively apply the complete algorithm, after taking the resultant of the previous line. Okay, so clipping and testing are done in fixed order. We have to follow the order. Okay, then it must be done recursively and efficient when most of the lines to be clipped either reject or accepted, not so many divisions. जब उसमें ज़्यादा divisions ना हो, ज़्यादा intersections ना हो, तो ये ज़्यादा efficient है कि जहाँ पे हम डायरेक्टली ये डिसाइड कर सकें कौन सा पार्ट एक्सेप्टेबल है, कौन सा पार्ट एक्सेप्टेबल नहीं है. Okay, so I hope you were able to understand what is line clipping algorithm and how we follow it, how we clip a line across the edges, and how we calculate the intersections across the edges. So in the next lecture, I will cover up one or two examples related to this line clipping algorithm numerically, so that you can better understand how we calculate the points, how we calculate the intersection points when the clipping cases occurred. Okay, so thank you all.